Representation, provides personalized local support, offering safety solutions customized to the needs of his clients across every major industry. Brian also has strong knowledge besides what he's going to speak about today, also on ANSI 810, ANSI C359, as I just talked about, OSHA 1910, OSHA 1926 for you folks in construction, ASTM F887, Arc Flash, NFPA ANSI Z87, along with a bunch of other stuff. Okay. So Brian earned his undergrad from Augusta College in Rock Island, Illinois, and has an advanced degree from Valparaiso University. Let's give Brian a nice warm welcome.
I don't like it tripping. Good morning. How's everybody? Good. Good morning. Good morning. So I appreciate the opportunity to come and speak to you guys. It's nice to finally start seeing some faces and get out into the real world again and have that opportunity to communicate and help each other out and educate as we move forward. So, but thank you very much for the opportunity for doing this. So what we're going to talk about today is two standards. I know we talked about kind of back and forth what we were going to do, but the first one, it's not changing. Moment, sorry. It is back in. Technical difficulties. There we go. Okay, so we're going to talk about two standards. The first one we're going to talk about is what Rich was talking about was ANSI Z359.14-2021 update, which is the new fall protection SRD update in regards to self-retracting devices. The second standard that I have up there is the ANSI ISEA Z308.1 2021 update, which gets into first aid kits, portable, non-portable, some of the different needs and requirements on that side of things. So with that, we'll talk about ANSI. So ANSI is a new standard, or ANSI has implemented a new standard that has since been postponed to, as Rich said, February 1st of 2023. I think a lot of that is due to the aspects of manufacturers not being prepared for the testing and where they have to comply to have product out there. So I'm assuming most of you understand who ANSI is, maybe not. If we have questions online, I'm guessing you would be the one to say if there's questions. Okay, so everybody's aware of who ANSI is? Yes? Mm-hmm. Okay, good. All right, so obviously ANSI developed the standard. I don't know where MIOSHA is going to be on this aspect. Sometimes MIOSHA will take a little bit longer to adopt that standard, but obviously ANSI's standard is February 1st. On June 17th, 2022, ANSI safety requirements were adopted or approved on the SRDs. The effective date was originally August 1st of 2022. After August 1st, 2022, manufacturers would have to comply to all of the new standard and the new testing that will go through on this. Okay. ANSI was first introduced in May of 1992. Their first and foremost upheld standard was 1999. In January of 2012, ANSI's Z359.14 was first published with specific language to the SRDs, or self-retracting devices, which became effective in August of the 20th of 2012. This is when leading edge classification was established. So all throughout the history of fall protection, we started out in belts and ropes and not even shock absorbing lanyards and where do we tie off? How do we tie off? Things of that nature. So as things progressed, we saw that we were moving the fatalities downwards, but we're still having injuries, new products come out, so on and so forth. So ANSI has changed to go along with that aspect of fatalities and injuries, and we lower the number and then it goes back up, so on and so forth. And that's just because the nature of new technology coming out. So leading edge was a big deal in around 2014. In 2014, you'll see it was revised with some safety requirements on SRLs and additional information regarding leading edge. That's because people were falling off leading edges with nylon cables and tearing away, and how do we protect that? So you started seeing integrated shock absorbers and things of that nature. In 2017 of last year, the most recent revision of the standard was updated and published. And you'll see that as we go through this presentation of those changes. So the first and foremost of the new aspect, and you'll see I've kind of put some parentheses around if it was updated or if it's a new aspect to the standard. But the biggest thing is for a manufacturer previous to this standard update was that we were using test torsos of 282 pounds. They've moved that now to a 310-pound test torso due to the fact that we're having larger people working at heights. We're having more equipment being carried up by individuals, both in the general industry and construction standard. We're maxing out the compliancy or the max aspect of SRLs and harnesses and things of that nature. For many years, when I was with a manufacturer of fall protection, you know, we always used to say our harnesses are good for 400 pounds. Well, there's another manufacturer that came out and said we're 420. And it's like, well, okay, your harness is that big, but we have retractables and lanyards that are only at 310. So we got kind of an issue there, right? So then you started getting into the game of, okay, well, we can stitch in some more stitching and now you're good for 400. And you add an additional shock pack. Well, now you're increasing your fall distance and your max arresting force and things of that nature. So as these things were all happening, we're starting to look at, hey, how do we minimize that force and keep it under what OSHA says is nothing over 1,800 pounds of force upon the body. Okay? They go on to update the classification for the SRL. So now we've gone away from Class A and Class B standards or classifications to a Class 1, Class 2, right? I know for those that are online are not going to have the ability to see some of this, but I brought along some fun toys and just remembering which one it was. Pass this around to it. You'll see on the label of this one, it says Class A, Class B. And many end users never knew that there was a Class A, Class B, or now that there's a Class 1, Class 2. So why I'm passing this around is for you guys to take the minute as safety directors or safety assistants, or you might not even be a safety director, but you're handling the safety protocol, is to look through and comply and see that your units are matching what is currently out there, right, as this kind of moves forward. So Class A and Class B have totally been removed. It's now Class 1 and Class 2, and we'll get into that discussion in a moment. You'll see on this slide the differences of the changes between the old Class A, Class B, and Class 1, Class 2. I know it's a very small slide on this end, but obviously you'll see between Class 1 or Class A and Class 1, the test torso of 282 to a 310 torso. The most must arrest fall within 24 inches. Now on the new Class 1, we go to arresting falls within 42 inches. So it went up versus that 24. The arresting forces are 1,300 pounds average, and then now the average is 1,350 as well. So nothing's changed there really. The test torso, and then obviously the fall arrest within 24 to 42 inches. Yes.
Is there a reason why they would increase the arrest from 24 to 42?
Yes. So because of the classification, now that there's so many different SRLs that are either worn on the harness that are personal or overhead, tying off at the feet, tying above the knees, where do we tie, how do we tie, leading edge, non-leading edge. There's a lot of parameters within where is it being at on the body. So I think what was going on is people were like, oh yeah, I can tie off at the feet with this unit, and you couldn't. Because the manufacturer said it had to be at 4 feet, not at foot level, or it had to be 3 feet. And people weren't reading the directions on that aspect. So now they've gone, okay, we're gonna have that max arrest distance of 42 inches versus that 24 inches. Because when that fall was happening on a unit that wasn't rated that way, the forces were way above that averaging of 1,300 or 1,800 pounds. So people were getting injured. So you were seeing that kind of injury rate skyrocket again, or people were using units that were not meant for leading edge, and now they're tying off at their feet and they're at a leading edge and they're going off a side and it's ripping through. So that answer your question?
Absolutely. Thank you.
Yep. You'll go on to see class B and class 2, the difference of the torso. And then the resting distance is printed on the label and instructions. So that's a new thing that has really come out, that it used to be 54 inches and the resting force of 900 pounds, because obviously you have a farther fall distance. You're developing a lot more dynamic forces. So now they're saying it's got to be printed on the label, and you'll see that later on in the presentation as we talk about that. We get into, excuse me, class 1, class 2, you'll see now they just say class 1 is anything that's anchored at or above the dorsal D ring. That is a class 1 SRD. Okay. Class 2 is anything that's anchored above or below the dorsal D ring. So what that means is basically when you're going around and looking at those SRLs, is it a class 1 or is it a class 2? Right in 2004, this started becoming real big with class A, class B. Before that, it was, what is your maximum fall distance? Are you gonna, minimize the forces under 1,800 pounds? Some manufacturers set up our max arresting force is 900, and some set arresting or averaging of 1,350. So it was, okay, where do we need to be? How do we do this? So I think as ANSI's moving forward is trying to get to a very clean way to identify fall protection, because back before 2014, I think it was pretty easy to understand how much fall distance I needed. But then you started to get into, all right, it's almost, and I'm going to age myself, it's the aspect of like beta, right? And beta max, VCRs, and then we went to VHS, and then all of a sudden we went to laser disc, and then we went back to DVD. I mean, so you get all these new technologies in cheaper, and it does the job better and allows for the employee to do a job easier. But we're starting to see that number climb again on fatalities. So how do we get it back to where it's simple and allows for that ability to work safely? All right. So when it comes to class 2 devices, it requires a integrated or integral energy absorber on the lifeline, meaning right into 2014, you started to get units that had integrated units like this, right? An integrated shock absorber. Inside here is also a braking system, right? But this was the answer to leading edge back before 2014. But now you're going to see this on a lot of the class 2 devices when it's being either anchored above or below that D ring. Okay. The energy absorber must meet that ANSI Z359 testing and also the Z359.13 testing. That's more for the manufacturer side, not for you guys. Class 2 SRDs, self-retracting devices, must pass a dynamic test over an edge with a 310-pound body, not a 282-pound test torso. The average arresting force must not exceed 1,300 pounds or 1,350, and a max arresting force not to exceed 1,800 pounds in ambient, and an average arresting of 1,575 pounds in condition. So ambient versus in a test facility versus out in the work condition. Okay. Again, not something that you guys really need to be concerned with. The more what you guys would need to be concerned with is that a class 1? Is it class 2? Are we tying above the head? Are we tying below the back dorsal D ring? They go on to talk about the categories changed to now SRL, self-retracting lifeline, SRLP, self-retracting lifeline personal, right? And then SRLR, self-retracting lifeline rescue. They got rid of the SRLLE, leading edge. Okay, that was this one. The reason for that is because now the leading edge is going to be in the SRLP side of things, because it's personal. Right? Under the ANSI Z359.14 2021 standard, you will now see kind of that breakout of the different products that would fall within those categories of class 1, class 2. So it's kind of like first aid kits. You have, you know, class A, class B, but then you have type 1, type 2, type 3, type 4, right? Same kind of category. They're saying, all right, here's a class 1. These can fall under it. Here's class 2. These can fall under it, but this is how the manufacturer has to manufacture that product to meet within those classifications. So class 1 is anything that's going to be anchored above our head, kind of the old SRLs, right? And then class 2 is going to be more personal. A lot of people used to use these personally, right? So people used to use these kind of units personal, right? But then all of a sudden people were putting these to their back and they were tying off at their feet. So then that's where we were starting to get the forces, because they're having more than almost the 6-foot free fall, depending on where they were tying. And are they 6 feet out and now they fall? You're developing more forces to be over that 1,800 pounds. So that's where then you'll see on here, there's no integrated or integral shock pack because it's internally, but it's also up here in the pack on those pouches on the units. You'll see an additional shock pack. Okay. That makes sense so far? Everybody's following me? Okay. Class 2 devices. You're going to have a clearance chart specifically for class 2. Okay. This is kind of a makeup of how far the setback is for your anchor point, how the distance you are on that axis from that anchor point, and then what your clearance is going to be required with that fall distance. I'll get into this slide a little bit more, a little bit farther on in the presentation. Okay. This was because a lot of people were not doing the calculation correctly. You know, we used to always talk about, you got a 6-foot lanyard, you got a 4-foot free fall distance, right? And then how high is your worker? So if we got 6 plus 4 is 10, 6-foot worker, 16 feet, and a 2-foot, you know, safety factor, right? So we always used to say about 16.5 to 18 feet of fall distance on a 6-foot lanyard. Well, now it becomes really complicated when you're tying off at your feet, you're 6 feet over here, you're over here, now you're swinging back to your anchor point, you're going across leading edges. There's a lot of new technology out there, so people really got confused on the aspect of that fall clearance. So ANSI said, nope, we're not going to have this anymore. Here's how it's going to be done when it comes to the class 2s, which that, if I go back a slide, you'll see the personal devices are underneath that class 2, which are going to be your leading edge and so on and so forth. Sorry about that. You good? Mm-hmm. All right. So let's go 2 slides forward. So the changes then, when we get into the SRLP or a class 2, is that the device with twin legs must hold 3,600 pounds of a load applied from leg to leg. Okay, so across the entire thing, and having that 3,600 pounds. So as a manufacturer, they have to hold 3,600 pounds. The SRLP devices are designed for tieback. So anything that's designed for tieback. So here's a tieback unit, right? Tieback used to be, okay, I can wrap around an I-beam and tie back to itself, right? My arm's the anchor point. So any of these type of units now must hold a load of 3,600 pounds, right? Static load. But that's also applied after the completion of 2,500 cycles of abrasion against that aspect. So they're going to run this across that edge 2,500 times as a manufacturer. And then after that 2,500 times, that's got to hold 3,600 pounds, is what they're saying. Why is that? Because these things are used every single day right around that I-beam, and they're rubbing against sharp edges and this and that. Somewhere, somehow, a fatality probably happened where somebody went and tied back to it, had the fall, and it ripped through. So that's where this testing, that abrasion testing, has come into play, being new on the personal units. Yes, sir.
Do we have an embedded safety thread in there? You know, like on your lifting?
Yeah, so a lot of times the edges of these used to wear through and you would have red showing on this, right? So this was done by Miller. This was Miller's turbo tieback. We didn't have a webbing on it, but the material that we were using as a manufacturer when this first came out, we knew we could meet and exceed the testing. But I'm sure you're going to start to see that in the manufacturer's guidelines, that if you see the webbing wear through, they're going to have that would be a failure.
Sure.
So as they're complying to that new standard, I'm sure that's something you're going to see. Yep. Or in the manufacturer's guidelines, they're going to say you need to protect that edge, that sharp edge. Even though you're tied back and this was to be tied back and it was sharp enough or durable enough for that tie back, they're probably going to say, well, you can only tie back this way. You got to ensure that any sharp edges are protected. Right? Good question. SRLP and class 2 devices do not need to retract after the overhead dynamic performance has happened. So if it's overhead and we fall, it doesn't have to retract back in its housing, is what they're saying. That used to be a thing that, okay, if it fell, this unit would be retracted back in. No, it could stay out. So during that dynamic, they don't require it to go back inside the housing. Class 2 SRLP devices shall include a clearance required label. That was that slide that I showed you with clearance numbers and stuff like that. Now every class 2 SRLP personal units that are tied to the back dorsal D-ring or the webbing of the harness is going to come with a specific clearance chart on where and how you can use it. And I'll show you that in a little while. All right. For SRLP devices which attach to the user D-ring do not require an energy absorber. I think that's more because a lot of times those units are specific in where they can tie off to and how far you can be from that anchor point, where it's got to be at your knee. And then I think that clearance chart is going to give that aspect that if you're in this area, you can use it. If you're not, you can't use it. SRP class devices can only have up to 40 inches outside the SRL housing when fully retracted. Okay? So this is a 7.5 foot retractable. Right? What they're saying, because you had the tie back, right? So from this point, we used to always say you could tie back around at that area, right? What they're saying now is the unit on personal SRLPs can no longer be a 5 foot unit. They can only be a 4 foot unit or less, is what that's saying. Right? Why is that? Because people were taking 7 footers, 9 footers, that one I passed around was a Scorpion. That was an 11-foot or 11-footer. Got the Black Rhino that used to be a 9-footer. DBI had a 9-footer, MSA has a 9-footer. I mean, there were so many different units. So people were taking those and going, well, I need a little more room. Now you're tying off your feet. Now you're increasing that fall distance. Now you're increasing that amount of force on the body. So they said, nope, we're not doing 5-footers anymore, 4-footers on personal units. So I think that's where some of the standards was pushed back because manufacturers are like, whoa, okay, well, we got to redesign some different things to stay within that standard. Okay. SRPs must pass a dynamic test with that 310-pound test torso versus the 282-pound test torso that we were testing before. Have that 6-foot free fall and keeping the arresting force below 1,800 pounds. Now that really kind of comes out into the OSHA standard that you got to have a 5,000-pound anchor point. You can't have more than a 6-foot free fall, and you can't have 1,800 pounds on the body, more than 1,800 pounds. So ANSI's just saying you're going to test it now to 310 versus 282 because we're seeing larger people out there in the force. Doesn't mean the body is larger. It means that they're carrying more nuts, bolts, tools, things of that nature. Okay. Question? All right. So class 2 SRLP clearance chart. This is what you're going to see when you start to buy SRLPs that are going to be attached to the dorsal D-ring or the weapon. So effective as February 1st, manufacturers, really August 1st, but manufacturers are going to have this coming into the product of those SRLPs. Okay. What you can see is it's showing that if I'm working and off my axis, so how far away am I? What kind of angle I'm going? So now we're going X, Y, Z axis versus just I was tying up above my head. And how did we shorten our fall distance? We went up higher. We used shorter lanyards. You know, we find shorter workers, right? That all has kind of gotten out of that, or lighter workers, right? Now we're looking at where is the distance? How far out are you going to go? If you're in this area, no, you can't do it. Yeah, you're going to have a 15-foot free fall. If you're 4 feet out from your axis and you're tied off at your feet, 13 and then 12. Does that make sense? They're really getting into the aspect because people were not doing the right calculations and hitting the ground. Okay. Questions? Any questions on that? Okay. When it comes to more of the changes on this standard, this gets into the webbing and synthetic rope in class 2 devices with minimum tensile strength of 5,000. It was previously 4,500. You know, being a class 2 and being attached at or above the D-ring or below the D-ring, I didn't see a lot of synthetic rope, but the webbing obviously is where that's coming from. So, you know, are you using tie-back units or things of that nature? But that webbing now has gone up in tensile strength because of, again, probably the leading edge aspect that's now incorporated into class 2. Okay. Static strength testing on SRDs must be able to withstand 3,600 pounds. So we're going to put a static load on your unit. It's got to hold it for at least 1 minute, and the lifeline has to be fully extended, which was previously 3,000 pounds. So now fully extend that SRL, and we're going to hold 3,600 pounds for 1 minute. Let's see how long that you can last. If you can't hit that, it's a failure, and now you got to figure out how you're going to do that. Why is that? Anybody have any reason of why that is? I'm going to test you. No idea, right? Yeah, you fall, right? The unit's seen 1,800 or maybe 1,300 pounds of force. You're hanging. How long should you be hanging on the rescue plan? Not long, right? Prompt rescue is what they talk about for fall protection. But we find that many times people will have the stirrups. Now they're standing in that harness, standing up, standing down, right? They're trying to alleviate that orthopedic suspension trauma. They might be hanging there for 15 minutes. They might be hanging there for 45 minutes. Your rescue plan might be 911, right? Obviously not what you can do or you should be doing. So I think this is coming into the aspect of, all right, they've fallen. Now it can hold that weight for that duration of time. I think before that wasn't in there at all. So just another step to ensure that if a person has fallen, it doesn't rip through or continue to go after the fall. Does that make sense?
Is that 3,600 pounds
Static.
static, but as far as, is that including safety factor or like absolute max, or is there a safety factor that they?
I don't know. I think it's just 3,600 max. I can check that and get back to you, but that was kind of an interesting way because they never used to do static load after the unit has been fully tested at the end. But most likely there were some manufacturers out there that might not be ANSI approved or meet some of the requirements that when they had that load happen, it wouldn't withstand that and they were going down. So, but I can check and ask. You know, I'm not within a manufacturer anymore. I'm dealing with multiple manufacturers, so I can ask that question and get back to you. Respond to you. It's all right.
Don't worry about it. It was
It's a good question. All right, class 2 SRDs must pass a dynamic test over leading edge. I think we talked about this. Yeah, this is something that I didn't get rid of for one slide. So we already covered that, I believe, right? Okay, SRDs that do not have an internal braking system now must hold a minimum of 1,800 pound static load while the brake pause or other brake activation system is engaged and locked within with it, at least 75% of the lifeline remaining on the drum. Okay, so what does that mean? You told them. So internal braking system means like this unit, when I lock up on it, right? It's locking that internal claw system. So it's binding into it and stopping and minimizing that, dissipating that force, right? This unit, all right, there's a shock absorber up on the top. So when I lock up, right, they will pop this shock absorber out of the housing and go from there. We grab that one that you had. Thank you, sir. Okay. So this unit doesn't have it. It's right here. Okay. So what they're saying is the SRD that does not have an internal braking system. This one is broken because this is one of my units that I use for testing. So what they're saying is, and you can see I had a failure on it. So I use this when I do my competent person trainings. What they're saying is, all right, 75% of the internal 9 foot should be still on that drum, right? And the pause of that locking should withstand that 1,800 pounds of static load. Okay, because they're looking to see if this is ripping up. That makes sense? So now this is gonna have to be beefed up, but also dissipate that energy, but then that internal braking or that paw inside can hold that force. Because there's been times that people use retractables for restraint. And they're putting that force on it and it pops that shock absorber out because of the amount of force that they were putting on it. So they were leaning into it and that shock pack pulled out. Now they went over the edge. So now they weren't in restraint. They're now in fall arrest. And they might not have had an anchor point that was rated for 5,000 pounds or 2 times the maximum arresting force by a qualified person. So I think that's what they're starting to look at is, okay, shock pack does still need to rip out because of the forces, but if you're using a retractable and restraint, that's fine. But we now need to make sure that that retractable isn't going to pull out and it can hold that static load. Make sense? SRDs must have the ability to dissipate their arresting forces. That, I mean, obviously is nothing new that's in that standard. All right, so the testing, this is updated. We've talked about this a little bit, a lot in it, 282 to 310. All right, so now with that 310 pound, their average arresting force increased from 900 pounds to 1350. Okay, what does that mean? So on some of these units, you'll see on this one, I'll pass that around. It's very small writing. I know I'm with you on that. It says 900 pounds maximum arresting force. See it there? Small. Right there. Maximum arresting the force, average. Right?
I don't know, I'll take your word for it.
Yep.
I can't see it.
All right, hold on. Let me see if I got a better glass. I didn't want to send around this one.
This is elder.
First one's kind of,
What's that?
that first one you sent around does have it on there. so-
Yeah. Okay, see here, this one's maybe a little bit easier to read. I'll send that one around. It's the third one down. Average slash max.
Yeah.
So a lot of them had average slash max. So some manufacturers had 900 pounds, okay? Some said 1350. Well, okay, it was average, right? Are we still below 1800 pounds? Yes. 900 pounds, I tell you, I'd much rather have 900 pounds of force on my body versus 1300, right? Because now we're starting to get up to that 18 and OSHA says, we can't get there. Well, the problem is I think some manufacturers said they had an average arresting force of 1350, but they were really closer up to that 1800. So now that they're increasing that weight, they're saying, all right, manufacturer, you better be hitting, you know, that arresting force at 1350, not being up here, because now you've increased. It doesn't seem like we've increased it much, but 282 to 310 is a fair amount of increase. Okay. The average arresting distance is shortened to 42 inches from 54. So now we've gone to the arresting distance is shortened to 42 versus 54. So we have a shorter distance.
Yeah, it's just you.
Right. Okay, where are we at? Would it be okay to take a break? Let me get some water. Okay, take a 5-minute break. Oh, sure, thank you. Is there?
Yeah, there's.
Yeah.
I'm just gonna jump out, just use the restroom. I'm dying to pee. We're good. Sorry about that. I don't know if I'm just getting older or the heat gets to me, but, get a little hot flashes there. All right. Average arresting distance is shortened to 42 inches from 54. That is a huge change, especially since you're going from 282 to 310. You've increased the weight. You're allowing for the arresting force to go up, which is fine because you know you're going to have that weight. But now you're shortening that fall distance to 42 versus 54. 54 was 4.5 feet, right? 42, now we're below 4 feet. So some manufacturers were there already, right? So the unit I passed around had an average maximum or average/maximum arresting force of 900 pounds. Their average fall distance was 42 inches on that unit, I believe, right? On that Scorpion that I was passing around. Let me make sure before I say something that I wasn't. All right, so the average maximum arresting force was 900 pounds. Slash 1,800 pounds when tested in the ANSI Z359.14 on this one. And then when tested the CSA, it was 900 pounds. So you can see the difference there, but arresting distance, 24 inches. So obviously this unit is going to meet that parameter, except for it's 1,800 pounds under ANSI Z359. So they got to get it below to 1,350 as an average, not max or slash average, right? All right, does that make sense on that aspect? We're really shortening that fall distance, which is probably going to be troublesome for some manufacturers out there, right? For conditioning tests, the average arresting force stay at 1,500, but the average arresting distance to 42 inches is now 42 inches. So conditioning this is in a conditioned environment versus ambient. Makes sense. All right. SRLR. So now we're jumping into the rescue side of things. All right. So self-retracting lifeline rescue. Function tests are the same, but static testing when in retrieval mode is now 3,600 pounds. So they're just increasing all of the static loading on these units. Okay. It's interesting in retrieval mode, and I don't understand why they're doing that, other than when it comes to retrieval side of things, I don't know if they're looking at the makeup of how much force is put upon the body, or is it a 3-to-1 or 5-to-1 for leverage of raising and lowering somebody on that. But again, it's nice to see that they've increased that, up into the higher numbers than what it was before. I think it's probably along the lines of the 310-pound worker as well. So they're increasing it for that. SRLs with internal brakes must pass a test with the lifeline shortened to 42 inches. Okay, so this unit, the Black Rhino, is a 9-footer. Okay. So what they're saying is shortened to 42 inches. So let's just say this is 42 inches. Right? Then have 36 inches plus or minus 1 inch clipped out of that unit. So they're going to take 3 feet in 37 inches or 3 feet out, and then have a 310-pound body weight free falling from 2 feet and must maintain 1,800 pounds. Why is that? Because when you had all this, you still had areas to dissipate that and keep it under that force. So now they're saying, no, you're going to be here at 42. We're going to take 3 feet out, and now you've got to have a 2-foot fall on that only 3 feet that's in there to have that force be under 1,800 pounds. So again, there was manufacturers that didn't test the ANSI. They were OSHA compliant. So, but ANSI's saying we're putting our foot down, you're gonna be ANSI compliant if you want to sell SRLs out in the industry. Make sense? All right, warning cards is required to be provided separately with each SRD. So any and all self-retracting devices that are now shipped out will have a warning card. And the warning card will say class 2 self-retracting devices or SRDs, when attached to foot level anchorage, pose significant risk of injury. The competent person and or qualified person should have all acknowledged that normal use of this device may not prevent a serious injury. Failure to follow all manufacturers' instructions warning may result in serious injury or death. People were tying off at the feet when they shouldn't have been tying off at the feet. People were tying off at the feet using SRLs in a restraint, but they weren't giving themselves the needed area for restraint. And they were falling off the edge without having a leading edge. All the things that we don't want to see, right? And everybody understands the difference between fall arrest and restraint, right? I should have asked that question earlier. Yes, okay, good. So obviously now manufacturers and ANSI are saying, nope, this has got to be in there now. You got to have a qualified person, you got to have your competent person, and the person that's using it all be in compliance and saying, yeah, we understand there's no serious injury. So that's going to be in every SRD now versus SRL. All right. As previously stated, SRD products that are manufactured after February 1st and in compliance to ANSI Z359 will be required to conform to the new standard. Okay. Any product that was manufactured before, so any of your stuff that's currently out there, can still be used, but it's got to follow the manufacturer's guidelines and requirements for inspection, and any criteria or any white papers they might put out there or anything of that nature. That makes sense. So you're still able to use it, but if you're a manufacturer, you're going to have to meet this. So you as end users still can use it, but this is where I like to throw in, okay, OSHA can adopt ANSI standards, right? They don't write them, but they can adopt them and then they'll enforce them through their the catch-all. General duty clause. Thank you. My mind was like general duty clause. So obviously, if there's a more stringent standard out there, OSHA is going to say you should have known this, you should have understood this, and this is where you should have been going. So what that means to me is that we should be looking at all of our products and slowly doing an update of getting all those things in place. If one, you're using personal SRLs, maybe in the construction, you should start looking at, are we compliant? Do we have the right product? And is that manufacturer testing? With that, I would say MSA, 3M, Miller, or Honeywell, and DVI is 3M, just if anybody didn't remember that. And then like Guardian and Faltech would be kind of your leaders in that side of things. There's been, since I've left the industry and kind of got back into some of this, there's so many different manufacturers out there that I was like, who are you and where are you from? And it's kind of scary in that sense. So, but I would just check on that stuff. Right. With that, that is my last slide. Are there any questions on that?
Yeah, Brian, thanks for this information. There's a lot of information, a lot of new information.
Yes.
I would imagine these devices cost more than, from a price perspective than the ones that are out there currently. And I know you can't put a price on somebody's life,
Right.
but what's your feeling or what's your sense on the industry, whether it's general industry or construction? Are the owners embracing this, that know about this, or are they saying just another regulation coming down our throats and we're gonna be forced to change into this?
So that's a great question. So if I was to put two different industries, 1910, right, general industry, 1926, construction, right? Construction is totally on board. Far, far, far more advanced than general industry. General industry has always kind of been lagging in that sense of updating and getting compliant. Construction is where a lot of that ANSI is being pushed. To the point that going on job sites and doing National Stand Down Week, and doing some presentations and stuff like that. We got general contractors or GCs that are requiring now, instead of hard hats, climbing helmets with whistles, and the construction industry is totally on board, and that's where a lot of this is going to be used. General industry, you're not going to find too many people that are tying off to their legs or at their feet. It's more going to be up in the air.
Right.
So, but construction's right there. Construction guys are wearing their harnesses 12 hours a day, every single day. General industry, hey, where did we put that harness like 5 weeks ago? Does anybody remember? Oh, it's right here on top of the bucket of oil. Oh, that's good. Let's go use it, right? So construction is definitely embracing it. You know, just like I said earlier, beta and VCR, right? Or VHS. When we get to Blu-ray, now I remember Blu-rays were so expensive. Now you can get like a $30 Blu-ray player, right? So you'll start to see that cost is going down on the retractables. Back when we started talking retractables, and I started with Miller in 2009, a regular lanyard was $60, $70. A retractable was $150. And oh, no, this, that. However, and I don't want to take up too much time, but there was a lot of times I was like, here, take this retractable, use it. Just tell me what you think. No, it moves too fast. It's going to lock up this, that, right? Had 3, 4 different people that had fallen on retractables and said, I will never ever use a lanyard again because of how fast they locked up. Yes, it was more of a cost, but it was more versatile than a lanyard. So you see that technology change in that. I know that was a long answer to yours, but definitely.
Right, and the other question I had is, and you brought this up a little earlier with the general duty clause, because, so what's your sense on OSHA's, I would imagine they're looking into this. Do you think they'll adopt this standard, or do you think they're gonna go with the general duty?
I think they're gonna probably eventually adopt this and add it in. I think they've slowly adopted ANSI over the years that they've been changing this. I mean, 2012 was the biggest change of that standard and how many different breakouts of that standard. And now we're at this aspect. And that is all because in, again, 90s, late 90s, we're still wearing body belts with non-shock absorbing lanyards, right? And people are like, full body harness, no way, I'm not wearing this. And you saw the change of it. But every so often, right, we see fall protection is always number one, or right there, number one, number two on the top 10 OSHA violations. So they're definitely there because we see a lot of fatalities in the construction side of things or injuries versus general industry. But we do get it in the general industry. We'll start to see that climb of the fatalities, and then all of a sudden something else, you know, changes it and it goes back down. Well, that's that technology, as we see, you know, when this unit came out, right, this was, and I'm not saying Miller, right, DBI, all those that had tieback units, right? So everybody was like, oh, okay, that's a tieback. Hey, I'm gonna use this and I'm gonna tie back to it, right? Well, it wasn't meant to do that. So the fatalities started going up. So as new products are introduced, you see the fatalities. So people now have these tied to their back versus being tied up over their head and having a tag on. Okay, well, hey man, this makes it much easier. I can attach here, I can attach down here, I can attach up here, I can attach back here. So there's a lot of user error where the fatalities start going back up. So I think you'll see probably using the general duty clause at the beginning. And I don't know if OSHA will ever change some of that. I mean, they're still at 5,000 pounds of 1,800. So I would say general duty clause for the time being and then eventually adopting it.
And then my last question or comment is, plenty of establishments I could foresee, whether it's GI or construction, will say, well, we'll phase it in instead of absorbing it all at one time.
Great.
So wouldn't there be a danger to even doing it a phase-in period? Because now you're not providing equal duty of care.
Right.
So somebody ends up getting squashed, you know, with the old or current equipment. I mean, I could see lawsuits occurring.
Yep. Yeah, I think it's gonna be a changeover and a training aspect to how we're gonna go about it. Toolbox talks, safety talks, what's our program state, so on and so forth. But yeah, this is a lot of information that is gonna be coming into the to the end user side of it. That I think a lot of people will still, I still go to customers now that have stuff that they're using lanyards still to this day. And I mean, 6-foot lanyards are not really common, but it's still kind of that cheap aspect. So I think you're gonna see it all across the boards. I think you'll see general GIs or general contractors definitely going to do this and pushing this. Manufacturing, general industry, probably not as much. They'll still be compliant. They'll have a competent person go through and check it. But I think your bigger companies, and I say bigger companies, when I throw bigger companies, John Deere's of the world, Amazon's of the world, US Steel, Lansing, Lansing Power and Light, Cook Nuclear, all those kind of things. They'll probably be more compliant on that versus kind of the bottom.
So do you offer like competent person training
I do.
in this?
Yeah, so, you didn't want me to talk about
Right,
that,
right.
but anyways, so I am a competent instructor for 3M. So I do the competent person 16-hour classes and the 4 and 8-hour classes in that sense. But by law, if you have fall protection, you're wearing a harness or a lanyard, right? You're required to have a competent person. It's not by law, it's in there that you should have a competent person. Competent person is what? A lot of people don't know. Well, a competent person is literally Rich saying, all right, I'm your new employee. You're our competent person. Okay, that's knowledgeable. Okay. Hopefully OSHA doesn't come in and then they're like, hey, who's our competent person? Oh, I am. Hey, what's the anchor point rating? But for your fall protection, oh, it's 1,800 pounds. Okay. How did you come with that? Well, the guy down there said, okay, is it certified? Is there a placard saying it's 2 times the maximum arresting force? Or are you just saying that's where we're tying off? Or, hey, we're tying off to the guardrail. That's perfectly fine, right? So acting as a competent person is not going to be a good thing. Knowing that standard, understanding it, being able to talk about it, is definitely something that you should have the knowledge and probably go to a class. I'm not saying you come to my class, there's plenty of them out there, but definitely get up to date on the standard. Anybody else? Yes.
So as kind of the qualified person and trainer for my company.
Yeah.
The data for falls, especially in construction, other than a report that just came out recently, it is extraordinarily difficult to find. Everybody that is a roofer or a sider knows somebody that's fallen and has had some significant injury or worse. But find somebody that has said, yeah, I was wearing fall protection and fell and it saved me, and I can't find it.
Right.
So I've not had that instance in my term.
Sure.
And I don't know anybody that can say, hey, yeah, I actually had a guy. I'm sure there's some, but
Right.
whereas when they are coming up with these standards, where do they get the data sets? Other than the fatalities, because everybody knows where to find that.
Right.
Other than the fatalities, where do they find the data that tells them that at this, they fell at this angle and swung this far? I mean, you can do the calculations, but there were no injuries or minimal injury or whatever. Where does data come from?
So I don't know exactly where all of it is coming from, but when I go back to when I was with Miller. So in that transition of lanyards to retractables, I was out doing one of those roadshow trailer demos. Has everybody seen one of those, right? All right. So I was doing one of those. I gave the guy a retractable. Not more than 2 days after I left, he was all mad at me, and I said, "Here, just try it," because he didn't want to go away from the lanyard. he actually fell off the ladder. And he was so elated and so excited and so happy about what happened, he reported it through the company. I'm not gonna mention the name of the company, but they made an immediate change to go to retractables corporate wide. We as a company, Miller/my team or myself, received an award and was asked to come to their corporate headquarters to receive that award because we did the right thing, got them into the right product. So knowing how and where they were, it was on a ladder, he was only 6 feet off, so we'd get a lot of that information. As manufacturers, on the ANSI committee, remember, it's a lot of manufacturers that are on there, so they're getting data, they're getting reports. They're looking at their testing, they're saying, we can do this, we can do that. A little bit is, hey, I think we could push maybe some competition out by doing this, right? But in the long end, it hurts some of the end users, but you also on the ANSI committees have end users that are part of it, that are possibly putting in some information from that. But a lot of it is kind of those near misses or those rescues that have been completed, that somebody has fallen and they're hanging over the highway or over a bridge. That's where they're getting that data from. But a lot of it is internally into the testing facilities at the locations of the manufacturers. And they're seeing that testing and that change and how can we increase or how can we better that standard and minimize the forces and minimize the risk of the manufacturer too, you know, because somebody uses their product at the wrong way or the wrong height, they have a fatality, they're going to be sued. So how do we minimize our risk as a manufacturer on that? But I know that's not the best answer for that. I really don't know. Maybe from insurance companies or just a conglomerate of all those companies that are on the ANSI committee talking about different things and how do we shorten it? How do we make it better?
So the best thing, just as maybe a resource, the best thing that I've seen thus far just came out, it's from the Center for Construction Research and Training. And it's called Underlying Causes of Falls from Heights. And that's probably the best data set that I've ever seen.
Yeah.
And it was based on, it was a survey, it was an industry-wide survey.
Sure.
And respondents had to have firsthand knowledge, either they directly fell or they were involved in an investigation of a fall and fatal or non-fatal.
Sure.
And that's where that came from. But that's, you know, for somebody that trains, people you want examples.
Right.
And, you know, this is how many people fell doing this work on this kind of a scenario. And this is the first thing I've ever seen that gives that information. I'm just wondering how ANSI.
Yeah, no, a lot of it is from the fatality aspect. It's really, but it goes back to what your website is, construction, is it? Senator,
The Center
Center
for
of-
Construction Research and Training.
construction. Right? Yeah, general industry, construction. So a lot of it is pushed through the construction world and safer. How can we be safer on those job sites and minimize those fatalities and so forth? You know, go back to the Golden State Bridge, right? When it was being built, all the fatalities that happened and then safety nets started coming into play and the safety world changed a lot in that. You know, we've all probably seen the pictures of the people building the Empire State Building, walking on I-beams and having their lunch and not being tied off and throwing hot rivets at 80, 90 feet up in the air. So, but yeah, I would say that a lot of it is from fatality. A lot of it is manufacturers trying to bring out a product that is going to be the better of the next or that new revelation and safety and fault. Yeah. Good information. Anybody online? No. How are we doing on time?
Oh, so we've got 15 minutes.
15 minutes? Do we want to? Yes.
Sure, I'll take a couple of it then. Can you roll back a couple slides? There was that half circle with the green and red and blue and those colors. Yes. Can you tell me what this all means?
Okay.
Walk me through,
So let me go,
you know.
go back to here.
Sorry, you guys
Nope.
got this.
That's great. I appreciate it.
I missed this one.
So you got a setback distance, X, right? And you got distance off of axis of anchorage, Y, and clearance of Z, right? So this is kind of that, all right, if you're 0 feet and you're 5 feet, you're in a good area. If you're at 6 feet and you're 5 feet from your setback, does everybody understand setback? No. Okay. So very, very new term, right? What do we always talk about? How do we shorten fall distance? How do we always shorten it? If we were working at heights, how do we shorten our fall distance?
Anchor point there.
Anchor point higher, right? Okay. Anybody else? Shorter guys, lighter guys. My son, who's joining us, we would throw him up there, right? Because he's 100 pounds. He's not going to pull out that shock pack as much, right? Okay, so that was always that way. Well, now what was going into, or what's been the new trend in the industry, is a lot of contractors are not going to fall arrest anymore. They're going to fall restraint, which is the best thing to do because we talk about the hierarchy, right? We always try to engineer it out. We try to do the control aspect. If we can't do it, we go to guardrail. If we can't do guardrails, we go to fall restraint and then fall arrest to the PPE, right? So fall restraint, everybody is going and looking for an anchor point farther back. Well, fall restraint, it used to only be 1,000-pound anchor point. Well, now fall restraint is 5,000 pounds. So you still got to find that 5,000-pound anchor point. Well, setback means I'm going to set my anchor point not here. I'm going to go 5 feet back. I'm going to go 10 feet back, but I'm also going to go up too. So I'm going to have an anchor point up, but I'm also going to set my anchor point back. That way I don't have it right here. I have it behind me. So I'm pulling out some of that distance on that retractable, but I'm allowing myself to still be able to get where I'm at with more restraint versus fall arrest. If I do fall, I still have a fall arrest unit, right? So that's kind of that setback distance they're talking about here. That makes sense so far? The clearance requirement is includes the 2-foot safety factor. So that's kind of talking about, all right, we got our 2 foot, we have our maximum fall distance that we're going to have on the unit, 24 inches, 42 inches, 48 inches, 36 inches. All manufacturers are different there because they manufacture differently to minimize the forces under that 1,350 or that 900 pounds or 1,800 pounds or average arresting force, right? And then the distance off the axis from the anchors. So how far am I going from that setback? So my setback might only be 5 feet, right, from behind me. And they're saying I can't go 6 feet from that distance from that anchor point. Because now what happens is if my anchor point's here and I go here, right? And I go and I work this way, my anchor point's back over here. When I fall, I'm going to swing back this way. So now they're doing a lot of that swing calculation. I'm sorry, I got out of the calculator or the camera there. But there was no one doing that swing calculation. So they were always putting their anchor point here, walking over here to do whatever work they needed. They fall, and now they go all the way across that leading edge back to here. And in the time of going across that leading edge, they've now hit the bumps in the and the concrete and the scaffolding and stuff like that. So that's where class 2, because class 2 is above or below, they were tying off back here because their anchor point was at their foot level, 6 foot behind them, and they were getting a 25-foot retractable with a leading edge protector. They were tying off at their feet. So they didn't have enough fall distance when that pulled out the height. Does that make sense so far on this chart? You following me? Right. So when I go here, what they're saying is off axis. So anchor point, how far off my axis? Am I 1 foot, 2 foot, 3 foot? So that axis, and then how far out I am on this axis. So if I'm here and I'm 3 foot off, I'm going to have 15 feet. They're doing an X, Y, and a Z like calculation on this, and it's When I came back and started my company and I was out of fall protection for a little while, I really struggled with the way that they're doing calculations. And I'll be the first one to say it as a competent, instructor for competent people. The way they do stuff now is so confusing versus what we used to. But that's because there's so many people doing so many crazy things with these personal devices that we're having so many fatalities than what it used to be as anchor point above us, behind us, restraint, what have you. But we got guys, I see retractables that are attached together. They got 50 feet and they're going all the way out. Manufacturers are saying, you can't do this anymore. This is going to come in here because we're going to cover ourselves now on these personal devices that people are tying off and going too far out. And again, that's where ANSI was like, all right, user, you're no longer going to have a personal device like this, right? You can get 2 of these, put into a carabiner, put behind your back D-ring at this point in time. These are 9-footers. Remember what I said? You're no longer going to be allowed a 6-foot, right? You're going to only have a 4-foot retractable now. So you're going to shorten up these. So you're going to have some guys in the union and the trades and stuff that are going to be really irritated when that comes down. So they're going to be staying in that old stuff because it allows them to do their job a little bit more. But manufacturers are saying, I'm going to cover ourselves now. And ANSI's saying you're going to cover yourselves. Is that, I hope I didn't confuse you, but what they're talking about is how far out on this circle, but really off the axis. So if you're 6 feet off your axis, so if you're 6 feet distance off that axis and your setback is 5 feet, you're in the clear 0 to 3 feet on that SRLP. If your setback distance is 5 feet from your back D-ring. So I'm here, I'm tied 5 feet off, right? And I'm working here, I'm fine. If I go 3 feet, right, from there, I'm still fine for fall clearance. If I go to 6 feet, I'm going down. And I don't have enough fall clearance. I'm going to develop enough weight. So what that's really coming to is 9-footers that are out there, 11-footers that are out there, people that are using, right? Step back doesn't necessarily have to be behind. It can be set back from my dorsal D-ring to where I'm tying off, right? Doesn't have to be 5 feet this way. I'm 5 foot 9 inches. My back D-ring to my feet is probably 4 feet. So that's my 4-foot setback. Does that make sense? So that's where they're saying, okay, if you're at your feet versus your knee versus here, that's that calculation that you're taking in place because, again, how much fall distance free fall can we have in the standard? Fall protection, 4 feet.
6, but they moved it to 4, right?
I moved it to 4. Well, that was on, yeah. On the, where's it at? Fall arrest within 42 inches. Class A, Class B. Class B, you can see must arrest within 40 to 54 inches. Arresting distance. So remember Class B, right? Now it's a Class 2 because Class 2 is going to be here, above or below the D ring. So that's going to be your Ps, your SRL Ps, right? They used to be 54 inches. Here used to be fall arrest within 24 inches on the Class A. Now they're at 42, and this is saying arrested distance on the instructions because they're now going to go to a clearance and say this is what you can use it at this level and not. Because there was never really an indication of, can I use this at my knee level? Can I use this at my foot level? Can I be at my calf level? Can I be at my waist level? So there wasn't that deflection out there on it, right? So when tying off at your setback here 40 feet. Now you're getting into bigger SRLs that are 40 feet behind you, because that's the closest anchor point that's 5,000 pounds, right? That a competent person feels comfortable with tying off to. They can be all the way 23 feet away from their access. Right? Does that make sense? Off the access versus. This is incompetent person training. This is where I lose so many people in the way that they calculate stuff versus I am 6-foot worker. I have a 4-foot free fall, right? Or deceleration with the shock pack and everything like that. How far out is it going to pull? Lanyards were 4 feet. Some of them were 3 feet, but we always went with the 6-foot worker of length of the lanyard, I should say, length of the lanyard, length of the height of the worker, your deceleration distance, and a 2-foot safety factor, right? Then they started getting into the aspect of, okay, well, it might be 5-foot worker and you got a 3-foot deceleration and your anchor point is this way and up behind you, because they were trying to minimize those falls because people were tying off in so many different crazy apps and applications. That makes sense? I hope I didn't confuse you more.
Clarify the action.
Okay. It's really coming down to manufacturers are going to say, this is how you're going to tie off on these units nowadays versus willy-nilly going out and doing what you want to do. Because manufacturers were trying to get their product into the construction going, hey, we got a leading edge. There's a leading edge unit out there right now that I won't bring up the name. The material of the leading edge is not this. The leading edge material is this. I don't know how that unit is going to meet the new standard. And that's where I think ANSI was like,
Is that
that happened.
Dyneema or something? Like what?
Yeah, because this is Dyneema. This is kind of more
Yeah, that's-
Dyneema and
it's
stuff
gotta
that
be
we are
in
using.
there.
It's stitching. But what they're doing is they're using this material to keep it lightweight.
Yeah.
Because the construction industry, hey, it's too heavy, I don't like it, I'm wearing it all day, it's wearing me down. Okay, so we made a lightweight with this one. They put an integrated shock pack for the leading edge. And everybody understands why there's an integrated shock pack, right? No. Yes,
Say it anyways.
what's that?
Say it anyways, just to make sure.
Okay. So here's a leading edge unit, right? Okay. So I go over the edge. And as this is ripping, I had the fall, right? So I hit and now I'm ripping and it's slowing me down. What was happening before was this would rip straight through because of the forces as it was going across the edge. But now when this hits and starts going, this sees that force and starts dissipating the energy on the cable. That's why these were here, to hopefully stop the person from fully ripping through and stop that person in the fall. That's where leading edge became big in 2014, was people were using these for leading edge, hit the edge, rip straight through it all the way down. Now we were like, okay, you hit it, you come, it's starting to slow down, this pulls out, minimizes the forces here, it saves effort. Does that make sense? Did you know that?
I guessed it.
I guessed it, all right. So,
Good clarify.
so that's where, now there's a unit out there, hey, we're the lightest one. And, it's Dyneema, it's a leading edge, but kind of scary. But I think that's why some of this change has happened. And all the ANSI standards generally change every 4 years. You see an update. It's like the NFPA standard. I worked with MSA and I was with MSA, NFPA standard every 4 years. We had new bells and whistles. And a lot of it comes from the firemen. The firemen are like, we're having a hard time finding guys. We need double repeaters. When they fall into we had a fatality. A guy fell down an elevator shaft. He was in a pool of water. We couldn't hear his whistle because he was upside down in the water and we couldn't find him. We couldn't locate him. So now, all right, if he's upside down, you got to have lights here. You got to have lights here. And so that's where a lot of this new stuff is. How do we help those be better?
On the SRLs are the rescue ones, are they embedding the rescue device right on the actual device?
It's always been that way. So here's ours.
Yeah,
So you can see a handle comes out
sure.
and you're retrieving. So when it comes to fall protection, there are units that when you fall, it locks up just like an SRL would do or an SRD would do. And then you pull a button and you can lower that person down or raise them up on a rescue type device, right? It's kind of your confined space units, Dynavacs, Mighty Vacs, trying to think of the name of the DBI. I think it's a Talon. This is Voltex units. So you're seeing a lot of manufacturers now come out with products for rescue because nothing against anybody in this room or online or anything like that. The rescue plan was, hey, I'm just going to pick up the phone and call 911. That's my rescue. Okay. Even in a city like Grand Rapids, the local fire department is not ready for a high angle rescue. They're going to have to call the regional team that will take 45 minutes to get out here or 45 minutes to get to where the trailer is to bring all the equipment to be ready to do the high angle rescue. So manufacturers are like, all right, we're going to just start putting stuff into our products. So I'm sure you guys have seen the DBI descent device. So if you fall and you're hanging there, you still can put your stirrups in and get that orthopedic suspension trauma off. But you can also take the little rip cord and pull it out and it will lower you down at a descended device of like 3.3 feet per second. Great product. However, not such a great product when you're over a vat of acid or you're over a grinder or something of that nature. In the mind of somebody that's hanging there, oh my God, I want to get down, rip, now they're going into a machine, right? Yeah. So I recently did some of that training on it, great product, but manufacturers are, how do we minimize that aspect of us legally? But I mean, at the same time, I don't want to say manufacturers are bad people. Manufacturers do want to do the right thing. They're in the reason for the manufacturer to get people safe, right? So there's more products that are coming out that have rescue type devices that even as you stop, it then gives like a couple seconds and then it will slowly descend down. So there are units that are coming out like that, all right, we've stopped you, everything's good, but now we're going to lower you down. So it integrated integral release of dropping you down.
It's still embedding rescue loops in the shock packs.
Not in the shock packs, on the side of the harnesses. So a lot of them are zip up or pull out suspension, stirrups. Some of the shock packs on some of the personal devices were doing that.
Yeah.
DBI was one of the biggest manufacturers to start the charge of putting shock or self-relief steps on their harnesses on every single thing. It was almost like, all right, we're Cadillac, we're going to give all of our harnesses with, self-relief steps. And then Miller kind of started doing the same. MSA, I think, has it as well, but yeah, they're definitely out there. So, back in the day when I did those trailer demos, we used to always say ABC's of fall protection, right? Anchor, body wear, connecting device. Are you talking rescue? And now we're talking D, descent devices. So ABCD, and are you talking rescue? So descent devices or dropped tool is another thing that people are talking about in the construction trade. A lot of injuries are happening from that. That's kind of changed in that sense. Okay, good. I know we were talking an hour, right? Yes.
Yeah, about an hour and a half.
Are we at an hour and a half?
Yeah.
Okay. All right,
So,
because I have the other standard, but I don't know time frame wise.
yeah, we'll probably have to do that. We'll probably have to invite you back for that one.
Well, it's in here. I gave it to you guys, but starting right here is the new first aid standard and the updates of the tourniquet, the bleeding control stuff, hazard assessment, and then the new classifications and stuff. So if you guys want to go ahead and pass it around your group, you can do that as well.
Right.
Or I can go back and do a turn. Sorry, I took a little time there. But it's great having the questions on it. It's a lot of information. While we're still on that fall protection, there is one more thing, that I thought I'd bring up to you guys. Anybody have fixed ladders outside their plant or in their plant? Yes? Got anything that's over 20 feet? Caged, that has a caged, fixed ladder cage?
Yeah.
That if it's over 20 feet, by 2036, cage ladders will no longer be allowed on anything over 20 feet. You will have to have a fixed climbing device. So if it's under 20, you still can have the meat grinder. Okay, right? If it's above 20 feet, try to find a way to shorten that ladder or put a staircase in, which would be the better way to go. But by 2036, there's no longer being the option of caged ladders.
So they're just going to cable.
Cable, fixed cable, or mounting an SRL up at the top. And all manufacturers, a lot of the bigger manufacturers have davit arms that can be retrofitted to your ladder system that can have an integrated shock pack and an SRL attached to it. And then have like a tagline, bring it down to you. Obviously, you always have that tagline. Don't do what I see all the time, is these things hanging out and like this all day long, right? You see a problem with that? What do you see? Exposure to the cable, right? So when the guy goes on a hooks, all that nasty dirt and dust and stuff can start to do that, right? But it also puts the internal components have tension on them all the time. So it breaks down the internal components of it. I have a tagline that you can bring it down to you or do a ladder device. By 2036.
Great tip.
Good
All right.
information?
Great information.
Good. I did my job.
All right, Brian.
Thank
Thank you very much.
Appreciate it.
Brian, we'd like to present you with something here. It's
Yeah.
a certificate of recognition. It says here, Brian A. Sebastian of Safety Distribution Services in recognition of your technical presentation on this date in Grand Rapids, Michigan. With knowledge shared, ensured our members to be up to date on the ANSI ASSP S or Z 359 standard safety requirements for SRDs and personal fall protection standards.
And we also have
Nice little book here. It's called Smart Brevity. I don't know if you guys heard about this one. It's the guys that came up with Politico and now they're Axios. And it's how to shorten your emails and stuff like that so you get attention of your readers. And it says here, Brian, the West Michigan chapter of the American Society of Safety Professionals appreciate and your efforts that you've expended on today's finest points of the ANSI ASP standards update. We wish you and SDS continued success, members of the chapter executive committee.
Appreciate it.
Very good.
I'm gonna have him take a picture later. So.
All right. Yeah.
All right. Is that, yeah, later.
We'll have you take
I appreciate it.
pictures.
I
Thank you
really
very much.
appreciate it. I appreciate your time and allowing me to come up here. It's, like I said, it's great to get out and see faces again.